Hi, today I will talk about green roof technology in civil engineering. So let's go. So what is green roof? A green roof is, you see here a picture, uh, in the roof, a covered with vegetables and a growing medium. This is the green roof, literally. So green green roof is built on the roof of the buildings and structures. So there are some benefits like it absorbs rainwater, provide insulation in the building, and you see when there is a concrete layer and there is a green layer, you most probably prefer the green layer. So it is aesthetically pleasing landscape and its lower urban heat island effect. What is urban heat island effect? I will talk later in my slide. So there is some potential benefit of green roofs. First of all, uh, effects on energy budget of individual buildings. I mean, it saves energy cost, effects on urban air quality. I mean, it reduce the pollution and other component like carbon monoxide, carbon dioxide. Effects on waste management from increase in roof material life cycle and promotion of horticulture, landscaping horticulture. There means you can cultivate different types of vegetables, fruits, and what you want on the green roofs. And promotion of biodiversity and wildlife protection. I mean, when there is green, there is some animals, some diversity, biodiversity. I mean, this is the place for habitation of animals and promotion on health and well-being. Definitely, green makes good health. Okay, and repercussions for urban amenities such as food production. Definitely, it makes food, aesthetics, recreation, urban agriculture, noise reduction, real estate, uh, therapeutics, and open space. So let's go. So I mainly discuss a project which was done uh, in the city of Toronto. They mainly did green roof technology benefits and its cost. So there are some association which related with this project. Um, First of all, Ryerson University conducted this project, and the fund come from Ontario's Centers of Excellence Earth and Environmental Technologies, and Troy Associates was the partner. For one, Richmond was also partner, and the city of Toronto demonstrated this 3-year $1 million project on the City Hall podium roof. And what is their objectives was? So their objective was types of green roofs technology, the measurable benefits of green roofs to the city's environment, and potential monetary savings to the municipality, and minimum threshold points for the City of Toronto to provide incentives to make significant cost savings. I mean, they mainly work on which green roof technology is beneficial and which technology is suited on the City of Toronto, and make a threshold value so that it will reduce the cost and it will be a cost saving matter. So there is cool roofs and cool pavements on energy use. Uh, there is some strategy like that. Cooler roofs, shade trees. It will reduce your air condition use. because when you are cool you do not need to use the energy. So when there is reduction use of air condition, and there will be less energy use, so reduces demand at power plants and less energy consumption. And cooler roofs, cooler pavement, and all vegetation. If all the places are covered by vegetation, then it will reduce outdoor temperatures, that will give slows reaction rates, and area sources emit less. I mean, uh, your cars emit some harmful components that will utilize by trees or green things. Then it will lower carbon dioxide, nitrogen oxide, and VOC levels, and ultimately it will lower ozone levels. So you see, the cool roofs and green technology, it will really good for our earth. So there is some researcher, it collects from different literature. So one of the literature on Mura Matsumoto, uh, he conducted that the evaporative cooling effect of a rooftop lawn garden showed a 50% reduction in heat flux in the rooms below the garden. These data also reveal reduction in surface temperature from 60 to 30 degrees Celsius during the day. And Ong did a project. He said that under a green roof, indoor temperature were found to be at least 3 to 4 degrees Celsius lower than outside temperature of 25 to 30 degrees Celsius. You see, when you build a green roof on your house, then it will reduce 3 to 4 degrees Celsius temperature. And Alcazar, they conducted that a green roof in Madrid reduced total energy consumption by 1% with 5.5% reduction in the heating season and a 6% reduction in the cooling season. And Del Vario, he conducted the total solar radiation absorbed by the planted roof, 27% is reflected, while the plants and the soil absorb 60%, and the 30% is transmitted in the soils. So if you constructed the green roofs, then it will absorb around 60%, and another 30% will absorb the soils. So this is the urban heat island. So urban heat island, mainly here you see there is a diagram. In the rural, that air temperature is less. Then when you go to suburban, it will be more temperature than the rural. And at the urban, the temperature peak is so high. So as the population density in the urban area is more than the rural area, and the heat heat air temperature is more than the rural area. So this heat concentration is called urban heat island. And these researchers show that Los Angeles could be cooled up to 3 degrees Celsius by green roofing. I mean, in the cities, if you make green buildings, all of the green buildings, then it will reduce 3 degrees Celsius around. So it's definitely a beneficial thing. So here we discuss 7 types of green roofs. First of all, this thing. So for more, and I will discuss in later. Let's show here. And let's go. Number 1. This is Sopranature green roof. So Sopranature green roof is typically used with its proprietary waterproofing membrane. I mean, this green roof have waterproof membrane. You see here number 1, steroid based stick. Number 2, Softline Lem Jardin, and there is some other component here discussed. And this is garden roof by Hydrotech. So you see here and this is a building on the roof. There is a garden roof, and the garden roof allows the design professional to transform virtually any flat or gently sloped roof into a landscape environment. I mean, you see, this is a really pleasant environment than this where there is no planted area. And the easy grain by elevated landscape technology. It in short form it's called ELT, elevated landscape technology. So elevated landscape technology, it mainly uh, it is uh, cultivated on a blanket, and they use the blanket where there is necessary. They use their roofs, roars, etc. So ELT Easy Green was the first to offer modular green roof and living wall technologies, and it is still leading with our innovative modular planters. And this is free cultivated vegetation blanket by Xero Flor Canada. This is a company, Xero Flor. So the green roof allows the design professional to transform virtually any flat or gentle roof into a landscape environment. You see here, they use the green roof blanket to cover the area. Okay. Now, Roof Neardo assembly by Roof Escapes. There is a company here from Canada, sorry, Germany. They use Roof Neardo in here. This is a beautiful. And green grid, uh, the green grid system, they use a small portion of grid to cover the whole area. So there is some advantages that easily access the roof, saves the cost of having to also repair the area of vegetation that must be distributed to access the roof. Green roof modules can be removed, set aside, and replaced once repair are made. I mean, if your roof is damaged by something, then you can replace this thing to other, and you can remove this thing without the destruction of the roofs. And green roof blocks, you see here, they use the blocks, and by using blocks they saves a lots of money, dollars here. And let's go, and there is some standard. The first only one comprehensive green roof guideline provided by the Germany, and their organization is their native language, and its short form is FLL. So they provide four criteria. First of all, they say that the green roofs uh, technology must have their water retention capacity of growing medium, water retention capacity of the drainage layer, number of plant species for extensive green roofs, and plant biomass or volume for in-situ green roofs. And this was quantitative, and this is qualitative. So there is 7 qualitative, 8 qualitative components: quality of soil, improvement in surface water quality, reduction in load of the sewage system, improvement in groundwater research, purification of stormwater, filtering of air, and contribution to our oxygen production, and contribution to thermal temperature leveling. I mean, if you want to build a green roof technology, then your technology should have this criteria. Without this criteria, FLL will not certify you. So you have to make sure that it reduce the load on sewage system. It purify the storm water, it purify the air, and it production the oxygen. That's it. And there is another guideline criteria is called Karlsruhe Performance Rating System, and there is five thing here, five factors, and it depends on type and depth of soil used, 50%, and impact on climate due to evapotranspiration, it is 15%, type and variety of vegetation flora, 30%, impact on zoological biodiversity, 30%, and average annual stormwater retention, 10%. I mean, your green roofs have must follow this guideline. And the Toronto projects and their methodology. First, they use the GIS to collect collection of buildings, street, stormwater infrastructure, watershed features with respect to their location. And the second one is it is short from the Toronto Wide Weather Flow Management Master Plan Study. And from this organization, they collect sewer networks with recent aerial photography, buildings data, as well as data submitted by the consultants. And the third one is city geographic records. And the from these geographic records, they collect the roof area, whose area more than 350 square meters, roof age, height, building use data were collected. And the fourth one is they use UFORD model to link the vegetated areas to expected air pollution reduction and economic benefits. I mean, vegetated area, how can it reduce the air pollution, and how can it gives the economic benefits? And they use this UFRO model. And this is their data collected from City of Toronto. And this is the data for buildings with roofs over 350 square meters by watersheds. You see here there is some river, Don River main, and yeah, so they use this uh, data for calculation. And there is another Toronto green roof study land use, and the land use commercial, education, industrial mixed open here. And there is Toronto green roof study CSO sewer shed. This is the sewer shed, how the sewer shed is located in here. And Toronto green roof study runoff reduction due to green roof implementation by watershed. So you see here watershed runoff reduction 5 to 7%. The highest is 11 to 13%. You see this area at the 11 to 13%. So it's a great achievement. And now I will discuss about green roof benefits and cost for the city of Toronto. And this is a table for impact on air quality from grass roofs, reduction in contaminants, and monetary impact. And there is a carbon monoxide, nitrogen dioxide, ozone, particle mineral, sulfur dioxide, and this is the cost savings. So you see here milligram per 109 hectare of green roofs area per year, and this is the amount they reduce. And direct energy savings from green roof implementation. So direct energy savings, it saves 4.15 kilowatt per hour per square kilometer per year. So it's a good amount of energy. And demand load reduction from direct energy reduction is reduced 0.0023 kilowatt per square meter peak. And this is the heat island effect reduction. So impact of reduction in urban heat island effect in Toronto. So direct energy savings is 2.37 kilowatt by cooling the city of Toronto, and demand load reduction from direct energy reduction is 0.00267 per square kilometer. So definitely it reduces the urban heat island effect. And there is a summary. It's a lot of data, so I cannot read it. Just if you need this thing, see here. And the initial savings, you see here there is five factor they mainly calculate. Urban heat island, they saves 25% of total cost. Stormwater 38%, combined sewer overflow 15%, air quality 0%, and building energy 22%. So this is the total percentage, the savings, initial savings, and the final annual savings Annual savings here, urban heat island 33%, and the biggest one is building energy 58%, and air quality 7%, and combined soil workflow 2%. And there are some recommendation the researcher made this. So I describe yeah. Extensive green roofs with a continuous coverage of growing media over at least 75% of the roof footprint of the building. I mean, if the green roof covers 75% at least, then it will give a good benefit. And another here, if your roof is flat, then it will disturb to drain water away from the roof. So they suggest that 2% of slope will make beneficial. I mean, the green roofs blanket will not hold the water. And another thing they say here, the green roof system should have a maximum runoff coefficient 50% based on annual rainfall retention of 50% for Toronto conditions. And there are other recommendations here. They said that a green roof with a depth of at least 150 millimeters should be considered. I mean, their depth should be must be 6 inches. It should be 6 inches. And here, green roofs with a growing medium thickness as low as 3 inches are available and can provide the benefits stated in the study. So in this study, they say they examined that 3-inch growing medium thickness can also be benefited for green roofs technology. And green roof system be designed and installed according to the manufacturer recommendation. It always say that you have to follow the manufacturer recommendations. And green roofs installed over air conditioned spaces that are heated and cooled provides energy related benefits. I mean, we have different spaces like a garage. The garage do not use the air condition, and there is no energy uh, thing. So where the places air condition use, there will be a good benefit from green roof technology. And thank you. I am Murad Al Quraishi, Department of Civil Engineering, and my university is University of Tennessee at Chattanooga. So if you have a question, please comment below the video. I will reach you as soon as possible. So thank you for to keep patient on my boring slides.